Warm welcome you all to channel Meet MIT, that is Math is Tricky. In this video, I'm going to share some tips and tricks about permutation. I'll be solving some problems and I'll be sharing some tricks also. So let's see how we can solve the problems of permutation. Okay, just by process also and with the help of some tricks also. Okay, here, let's start. Find the number of permutation of 5 different objects taken 3 at a time. Okay, so it means that there are 5 objects. First question, 5 objects, and from which we have to take only 3 at a time. Means here we have to fill 3 places with 5 objects. So for first there will be 5 choice, for second there will be 4 choice, for third it will be 3 choice. So 5 into 4 into 3 will be here 60 as your answer. Also this is first method. So second method can be used here as second method. N will be here 5. Out of 5 we are taking out only 3 objects, so we can use here number of permutations will be here just simply p and 5 3. So if we use formula for this 5 factorial by 2 factorial, it gives here 5 into 4 into 3 into 2 factorial by 2 factorial. We are getting the same answer here, 60. You can check here. Also to solve this, so what we can do here, we can use here a trick here if you want to do or solve this by trick. So trick is simply here, so p 5 and 3 for this, simply write here, start from 5 and write here 3 numbers, 5 4 3. That's your answer here, 5 4 3, that is again 60. The answer is 60. Okay, hope you understood this. And why we are using here a formula of permutation, because this is the already mentioned. Also first one thing you have to note is that permutation, it is written here. Also we have to take the numbers, and if we change the position of number, the value will also change. That means order matters here. So it is problem of permutation. We must use formula of permutation. So second question is there. Let's see question number 2. Question number 2 here. The first one solved. So now go for 2. If 3 persons enter a bus in which there are 10 back-end seats, 3 persons enter in a bus in which there are 10 back-end seats, in how many ways they can sit? It means here for 2 number, let's see here, 3 persons are there, 3 persons and 10 seats. Okay, so in how many ways they can sit? So it means n equals 10, r equals 3. So required ways will be simply here p 10 and 3. And if we use formula for this, we'll be here getting 10 factorial by 10 minus 3, it is here 7 factorial. By cancellation we'll get here 10 into 9 into 8 into 7 factorial by 7 factorial, cancel, and then we'll be getting here 720. That's our answer. Also this can be solved by trick here. Trick is also by basic principle of counting we can solve this. So 10 seats and 3 persons. So for first person there will be, write like this, 1 2 3. For first person 10 choices, for second person 9 choices, for third person 8 choices. So if you multiply these all choices, you will be getting here same answer. Also this can be simplified, this See here, simply uh, P, 10 and 3 by trick also. I just told you how we can simplify here. Let's see here another method so that we can solve this within just second. So again here trick is simply, rather than using formula, you can just write here P, 10 and 3. As I told you, you can just write here, start from 10 and come down 3 steps to 10, 9, 8. Answer is again 720. That's your answer. This number, question number 2 is also solved. So if you understand this trick and if you follow the tips and tricks that I'm sharing, you'll be able to solve the problems just within seconds. Okay, hope you are understanding this. And let's move to now question number 3. Question number 3 is, how many number plates of vehicle consisting of 4 different digits can be made out of the given integers 4, 5, 6, 7, 8, 9. That means 1, 2, 3, 4, 5, 6. We have here digits of 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. We have 6 digits, n equals 6. Now we have to choose only 4, that is r equals 4. So required ways will be simply required ways we can write here. That means you have to make a vehicle of, we have to make a plates of number plates of 4 digits. So it will be here simply P, 6 and 4. So answer will be simply here 6 factorial by 2 factorial, and it can be written as 6 into 5 into 4 into 3 into 2 factorial by 2 factorial, which gives here 30 into 12, it is here 360. Also we can use trick here to solve this. We can use trick also. Okay, so we have to choose 4 digits. So right here 4 space 1, 2, 3, 4. For first place there are 6 choices. For second place 5 choices. For third one here it is here 4 choices. For first, second, third and fourth one will be here only 3. So if you multiply these all choices by basic principle of counting, we'll be getting here so 30 and 123, 60. Again answer. Also we can use here, instead of using formula direct, we can use here. So answer will be 6p4. It means here, as I told you, start from 6 and go down 4 steps. So 6 into 5 into 4 into 3. Again we'll be getting here 360. Okay, hope you understood this. 4 boys and 3 girls be seated in a row containing 7 seats. There are different conditions. Okay, so question number 4, here boys, number of boys is here 4, girls, number of girls is here 3. Now first question, for first, if they may sit anywhere, that means there is no condition, there is no restriction, so they can sit anywhere. So it means here n will be 4 plus 3, that means 7. Also there are seats, they have to sit in 7 seats. You can see here 7 seats. So R is also 7. So for 7 persons, they can sit in 7 seats in 7 factorial ways. Okay, so simply it is here 7 into 6 into 5 into 4 into 3 into 2 into 1. simply it is here 5040. That's answer. Okay. Question number B. For B, this is first one. For B, if the boys and girls sit alternately, if they have to sit alternately, so let's sit here first. Arrange for boys B, 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 and B. There are 4 boys. Now they can sit, boys can sit here in 4 factorial ways. Now for the remaining girls, and girls here, they have to sit here. So girls, and here girls, first, second girl. So they have to sit in 3 factorial ways, because this is the arrangement. 2 boys will be there, and in the middle 1 girl will be there, so that they are sitting alternately. So it will be simply here 4 into 3 into 2 into 1 into 3 into 2 into 1, and it is simply here 12 into 2, 12 here, 6 and 6 36, 4 into 36, so it will be here 4 and 144. Okay, you can multiply this simply here, so 160 minus here simply 24, 4 3 are 12, and then 144. So this is our second part. Now for third one, if we see here, so for third condition, so here, if 3 girls are together, that means here girls, girls, now they will be considered as one, remember, eh? So, and the boys will be there, boys, and boys. It means here it will be simply 1, 2, 3, 4, 5. Consider all girls as one, as they are sitting together. So it will be here 1, 2, 3, 4, 5. So they can sit in 5 factorial ways. But these three girls can change their position among themselves in 3 factorial ways. So it will be simply here 5 into 4 into 3 into 2 into 1 into 3 into 2 into 1. You can use calculator also. 1, 5 for the 20, 20 into 6, 120 into 6. Yeah. So it will be here 120 into 6. So 720 is our answer. Also an extra question we can make from here also. If all the boys are together, so suppose here girls, and all the boys are together now, boys. So in that case, there will be 1, 2, 3, 4 persons. They can sit in 4 factorial ways, and boys can sit in 4 factorial ways. So 4 factorial will be answer. So how much we can write here? 4 factorial into 4 factorial. That is going to be our answer. Hope you understood this. Now let's move to another question. Question number 5. Question number 5. The question is here. This one. In how many ways can 8 people be seated in a row of 8 seats? People, 8 seats, 8 in a row they are sitting, so that 2 particular persons are always together. So that we have to sit, so that always 2 particular persons are together. It means here we have to consider 2 persons as one. So suppose here persons P1, P2, P3, P4, P5, P6, P7, P8. There are 8 persons, but always 2 persons are sitting together. Means it will be simply 1, 2, 3, 4, 5, 6, and 7. 7 persons are there. They can sit in 7 factorial ways. And what we have to do, 2 particular persons are always together, means they should be considered as one person. Okay, so and they are sitting together, so treat them as one person. Now follow the process, follow the way or the rules that we have. So now, but they can change, these 2 persons can change their seat among themselves into factorial base. So it will be here 5, 7 factorial is 5040, and this is simply 2. So it will be here 10,000 5048 is here, 10,080 will be our answer. Hope you understood this. If you have any confusion, don't forget to share with me. Don't hesitate to share with me. I'm always for you. I'm always there to support you all. Okay, I'll be happy to support you all. Whatever videos I'm making, it's all for you. Okay, so remember that only the way is to excel in mathematics is do the problems, practice a number of times. By practice only you can excel with mathematics. We have 6 books. Okay, total number of books is here 6. Now what we are going to do? First condition, 2 books are always together. So suppose here B1, B2, B3, B4, B5, B6. These are the 6 books, but always these 2 books are coming together. So this can be considered, this must be considered as 1. So it is here 1, 2, 3, 4, 5. That means there will be 5 books which can be arranged in 5 factorial. But these 2 books can change their positions among themselves in 2 factorial ways. So it will be here 5 factorial means 5 into 4 into 3 into 2 into 1 into, this is 2 into 1. So 20, 120 into 2, here 240. That's your answer for first part. For not together, the ways in which the 2 books will not be together is simply total number of arrangements minus here. For B not together, for not together, we can write here ways required will be simply here total arrangements minus coming together means 240. So total will be simply here 6 books, so 6 factorial minus 240, and it is here 6 factorial means 720 minus 240 will be getting here 80, and 6 minus 2 is 480. That means the total number of ways will be 480 if they are not together. This is how we can solve. So always if you have to find coming together, you consider them as 1, and then if they are, you have to find the total number of ways in which they are not together, find total minus coming together. You'll be getting the answer. Let's move to question number 7. Another question. This is first one we have already solved. Now move to 7 number. 7 number, the question is here. In how many ways can 4 red bits, 5 white bits, and 3 blue bits be arranged in a row? Okay, so it means here we can see here 4 red bits means red equals 4, white equals 5, and blue bits. Blue is here 3 blue bits. So altogether n will be simply how much? 4 plus 5 plus 3, it gives here 12. Okay, 9, 12, and then here it means here 4 bits means 4 objects are of same type, 5 objects are of same type, 3 objects are of same type. So required which will be simply here n factorial. You can consider this as p, q, and r. So it will be n factorial by r factorial, p factorial, q factorial. This is the formula in which some objects are similar. Okay, so in that case it will be 12 factorial by 3 factorial, 4 factorial, and 5 factorial. Please you simplify this, you will be getting the answer. This is the type in which all the objects are not different, all the objects are not distinct, some of them are similar. Okay, so this is how we will solve these problems. This type of problem will be solved in this way. Now question number 8. To solve this, how many ways we can arrange the letters of element for element A, L, E, M, E, and D. So let's count here. 2 is, yeah, 2 is, let's write here, equals P equals 2, 2, 2 and 2. 3 is are there, so it will be P equals 3, and 1, 2, 3, 4, 5, 6, 7, n equals 7. Now we can see here no other elements are repeated here, so required wage will be, for this required wage will be simply here 7 factorial by 3 factorial. So simplify this, 7 into 6 into 5 into 4 into 3 factorial by 3 factorial, these two cancel, so it is simply here 20, 120 into 4, 840 will be the answer. Okay, for next word, maybe whatever, maybe the word, sometimes there is business, sometimes it is commerce, sometimes errands, some words are taken but the process is same. In this word you can see here all the letters are not same, so this is how we'll solve. In this type of problems, always take the total number and divide by the repeated number. So for notation, NOTATION, so 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8. Now this n is coming one time and two times. So b equals, it will be here 2. Again t 2 times, so q equals 2. O coming 2 times, r equals 2. And now others are different. You can see here a is only one time, I is only one time, 6 and 2, 8. So wage will be, required wage will be simply here 8 factorial by 2 factorial, 2 factorial and 2 factorial. Similarly we can write for mathematics. So mathematics, in case of mathematics, let me write here mathematics, it will be simply mathematics, M-A-T-H-E, you can see here mathematics, M-A-T-I-C-S. Okay, so let's first count the total numbers. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so n equals 11. Now see here, this m is coming one time, twice it is coming here, so p will be 2. For the repeated, you write here a is coming here one time and one time here 2 times, so it is here q equals also 2. For t, it is here coming one time and one time, 2 times, r equals 2. Again here h, what would yes, it is coming only one time, then m is already taken here, I is coming, so okay, 2 times, so which will be required, which will be here, so 11 factorial by 2 factorial, 2 factorial and 2 factorial. Okay, so you can see here is 2 plus 4, 4, 2, 4, 6, so 6, and then 7, 8, 9, 10, 11. So M-A-T-H-E, mathematics. This is our answer. Okay, so the last one, let's see also how we are getting answer for that. So for Mississippi, M-I-E, double S-I-E, again here double S, Mississippi, double P-I. So let's count the number of 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Okay, so again here you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equals 11. So m is coming only one time, so 100. I is coming one time, 2, 3, 4. So p equals, it is here 4. For s, 1, 2, 3, 4. S is coming also 4 times, q equals 4. And then p is coming 2 times, so r will be 2. So required wage will be required ways will be simply here. Whatever odd is given, is just right here. N factorial means 11 factorial by 4 factorial, 4 factorial and 2 factorial. 8 to 10, only 1 is not coming, repeating here. Yeah, Mississippi. This is how we can solve the problem. Hope you understood this. If you have any confusion, please share with me. How many numbers of 6 digits can be formed from the digits 2, 3, 2, 0, 3 and 3? We have here 1, 2, 3, 4, 5, 6. 6 digits. We have to make a 6-digit number with 6 digits. So 1, 2, 3, 4, 5, 6. Let's write here 6 spaces. We have to form for 6 digits. For 6 digits. For 6-digit number. 0 cannot be placed at 6th place. Okay, otherwise it will be 5 digits. We can't put here 0. So for this place we have except 0, 1, 2, 3, 4, 5. 5 choices. Now we can put here 5 digits for 5 places, so it can be written as here 5 factorials. Okay, so but we can see here 2 digits are repeated, so answer will be 5 into 5 factorial by 2 factorial. Again these 3 are repeated, 1, 2, 3, so it will be here 3 factorial. So which required will be simply here, simply we can write here 5 into 5 factorial means 120 by 2, this is 3 factorial means 6, 12, so it will be here 10, answer will be 50. Hope you understood this. What is the main point you have to note down is at starting, okay, for 6th place we can't write here 0, so we have only except 0 5 choices. Now for remaining 5 choices there will be 5 choice, 4 choice, 3 choice and 2 choice and 1 choice. That means these 5 remaining places can be filled with 5 digits in 5 factorial ways. But as these two numbers, these two digits are repeated, so we have to divide by 2 factorial. Again this 3 is coming 3 times, so we have to divide by 3 factorial. That is how we can solve this. Hope you understood this. Now let's see another question. Question number 10. Number 10. In how many ways 4 art students here, 4 science students, again 4. Now for first part, they can sit anywhere, means total students n will be simply here 4 plus 4 equals 8. But in case of circular table, the answer is which will be simply n minus 1 factorial. It is here 7 factorial. Answer is 5040. Okay, for second part, if they sit alternately, means let's first make them these art students. Let's first let them sit. So art students, 4 art students, 4 art students, they can sit in 4 minus 1. If factorial ways means it is here 3 factorial, it is here 6. Now remaining 4 places can be taken by 4 science students, and it can be done in 4 factorial. It is here 4 into 3 into 2 into 1, 6 and 24 ways. So required ways will be required ways equals here 24 into 6. It is here 24 and 2, 6 here 12 and 2, 14. So 140. So what I actually did here, first I have made these 4 art students to sit in a circular means in a round table, and it can be done in 4 minus 1 3 factorial ways, which is 6 ways. Now if 4 art students are sitting there, so there will be 4 spaces, so that can be taken, that can be occupied by 4 science students in 4 factorial ways. It is 24 ways, and now if you multiply, you will be getting here 140 ways as the total required ways. Okay, so this is how we are solving. Let's see another question. Question number 11. Yeah, so number 11 is, in how many ways 8 people be seated in a round table if 2 people insist in sitting next to each other. Okay, so total number of people is here 8. They have to sit. Suppose here P1, P2, P3, P4, P5, P6, P7, and P8. These are the 8 peoples, but two two peoples are always sitting together, so that will be considered as one. So it will be here 1, 2, 3, 4, 5, 6, and here 7. That means 7 people can sit in a round table. Remember, right? Note down. Always in the case of circular arrangements, the total number of ways will be n minus 1 factorial for n objects. So for 7 people, they can sit in 7 minus 1 factorial. But these 2 people can change their position in 2 factorial ways. So it will be here simply 6 factorial into 2 factorial. 6 factorial is here 720 into 2. Answer will be simply here 14 and 0. Okay, so 1440. 1440. So 1414 is our answer. Hope you understood this. If you have any confusion, share with me so that I can support you, so that I can help you. I'm always there to support you, always there to help you. Please practice well, try many more problems, do many more problems, and boost up your mathematics. Thank you so much. God bless you. Can 7 different colored beads be made into a bracelet? Okay, remember, in case of bracelet, necklace, we have n minus 1 factorial by 2. This is the formula. This is the circular arrangements. In case of circular arrangements, also clockwise and anti-clockwise will be same. So in this type of problems, for bracelets and necklace, the formula is n minus 1 factorial by 2. So this is required ways. So answer will be here. Answer will be simply here 7. 7 bits means 7 minus 1 factorial by 2. It is here 6 factorial by 2. 6 factorial means here 720. Okay, and by 2 is here 360. Our answer. Okay. Let's move to another question. Question number 13. 13 number. Question number 13. How we can solve this? Question number 13A. First question. In how many ways 4 letters? 4 letters. We have 4 letters that should be posted in 6 letter box, 6 boxes. So simple, it's very simple. For first we have 6 choice, second again 6, third letter it will be again 6, and fourth again we have the 6 choices. So required ways will be simply here 6 into 6 into 6 6. It is here 36 into 36, and it is simply 1296 square of 36, or that is here direct you can write here n power r. It is here 6 power 4. Okay, this is also the way to solve this. 1296, it is simply 36 square. 36 square. Okay, so let's see another question. Question number B. 13B. How can we solve this? In how many ways even numbers of 3 digits can be formed with the digits in which the repetition of digit is allowed? So we have to form a 3-digit number, but it should be even. For even, we have only choices for unit place: 0, 2, 4, 6, 8. 1, 2, 3, 4, and 5 means 5 choice for unit place. Now the second place, that means 10th place, can be occupied by any one of the 10 digits. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have 10 digits: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for unit place, we have only 5 choices: 1, 2, 3, 4, 5. Now 10th place can be occupied by any one of these 10 digits, because we can repeat the digit. So choice will be 10 here. Now to get 3-digit number, we can't put this 0 in third place or 100 place. So we have only 9 choices. So our required wage will be, wage required will be simply here 9 into 10 into 5. So here's 450 will be the answer. Okay, so hope you are getting this. So last question, number C. We see here 13C. In how many ways 3 prizes can be distributed among 4 students so that each student may receive any number of prize? That means first prize, for first we can write here 4 choices, second again 4, for third also 4 choices. So that is, we can write here 4 or 3. Answer is simply 64. That's our answer. Hope you are getting it. This first prize is, the first prize can be distributed among any one of the 4 student. Second also will have 4 choices. For third prize also 4 students. So the total number of which will be 4 into 4 into 4. That is 64. That's our answer. Hope you understood this. Thank you so much. God bless you.
Thank you so much for watching my video. I hope you like this video. Please do share this video with your friends, in your circle, in your social media, and please don't forget to subscribe my channel. Thank you so much. God bless you.